So let's now see about the extraction of moderately reactive metals. So in the previous session, we discussed about what is a mineral, what is a ore, right? So a mineral is any compound of the given metal which is available in the earth crust. But ore is one thing from which we can extract the metal more freely, easily and economically, right? And now to extract the moderately reactive metals, the best of their ores should be selected, and the method what we are following always depends upon the ore what we have selected. For example, if the ore selected is sulfide ore is sulfide ore, then what we do is we will make the roasting process. So in the previous sessions we have discussed. So sulfide is roasted to convert into its oxide. Okay, so what is the procedure we follow? If the metal is means the ore what we have selected is sulfide ore, then the sulfide ore is roasted so that the sulfide ore is converted into the corresponding oxide, right? And if at all the ore selected is carbonate or hydroxide ore, okay, carbonate or hydroxide ore, then we have to calcinate the metal, means compound is calcinated to give its oxide. So about roasting, we already discussed in the previous classes. What is roasting? Roasting is heating of metal sulfide in presence of excess of oxygen to convert it into its oxide, right? Now calcination is similar to roasting. So calcination is very similar. The only difference between the calcination and roasting is roasting will make in presence of excess of oxygen or excess of air, but the calcination is heating of metal ore in absence of air. Alright, so here calcination or roasting, either of the processes are that the main aim of all these processes is to convert the given metal sulfide, carbonate or hydroxide ore into the corresponding oxide, right? But if the given ore, selected ore is a sulfide ore, we will use roasting process because roasting will convert the sulfide into its oxide. But anyway, roasting process has to be done, means the process must be carried out in presence of excess of oxygen, right? And carbonate ores or hydroxide ores, if they are present, for that we need not to take the oxygen, just heat the metal in the absence of oxygen, and either roasting or calcination has to be done below the melting point of ore. Okay, so here in the absence of air and heating should be below melting point of ore. We should never heat the metal to above its melting point. Now for this, as an example, we'll take one, that zinc carbonate. See, this is a ore from which we can extract the zinc, right? Now the carbonate of zinc, whenever we heat it, it will decompose to give its compound ZnO with the release of carbon dioxide. So in this way, we have converted the metal sulfide or metal carbonate or metal hydroxide, all these ores, into the corresponding oxide ores. Then how to get the metal from the oxides? From the oxides, just treat it with any reducing agent, right? Means the oxide. See, for example, zinc oxide is there, right? Now the zinc oxide can be treated with carbon, which is the reducing agent here, so that we can get Zn plus Cu. Okay, and the reducing agent what we have selected should be more reactive than the metal what we are extracting here, and at the same time it should be more economic, right? So the whatever may be the metals which are less reactive, than carbon can be reduced by carbon, right? And similarly, if at all we want to take iron, right, Fe2O3. Even for the iron reduction also means conversion of iron oxide into iron is also extracted with carbon so that we can take carbon monoxide as a release so that iron metal can be extracted, right? So the reducing agent means oxide can be converted into its metal by using any of the reducing agents. So what are the better reducing agents we can use? So reducing. So what reducing agents we can select? In many of the cases, the reducing agent selected will be carbon or carbon monoxide, right? So this is the reducing agent what is being selected in most of the cases, right? If not carbon or carbon monoxide, we can use metals like sodium, magnesium and aluminium, right? So example, aluminium is one metal which is used in aluminothermite process. In aluminothermite process, to reduce the same iron, we use aluminium. So Fe2O3 plus Al gives us Al2O3 plus Fe. And a very important thing is that this reaction we use in means making of railway tracks, because here we can cast the iron to the required shape, because this reaction is highly exothermic because the aluminium is the strongest reducing agent, and because of that reason the reaction, after the reaction the metal is obtained in liquid state, because it will produce large amounts of heat and the heat generated can liquefy the metal, means can melt the metal, so that the iron will be directly available in the molten state and we can obtain or we can cast it to the required shape, right? So like this we can use any reducing agents. The reducing agents can be the elements means most cheaply available elements like carbon or carbon monoxide, or sometimes we can even use the reducing agents like more reactive metals like sodium, magnesium or aluminium, right? So like this, any reducing agent, proper reducing agent. Now on what basis we can select the better reducing agent? In the sense, it is very simple that the reducing agent, whenever it gives reaction, the reaction should be more exothermic, so that it has to give release of more temperatures and reaction should happen very fastly, right? After that, the reducing agent what we have selected must be more economic, in the sense cheaply available, right? So such any element we can select it as a reducing agent. Yes, have a look now.